Hi everyone. Thanks for thanks for logging on again for another JavaScript in London. Apologies, we haven't had one for a couple of weeks. Unfortunately, we've not had any speaker available. But yeah, tonight we've got Will Britton from Tempo, and I'm sure it'll be a very interesting chat. If anyone is interested in giving a talk in the future, as always, please do get in touch. Not sure if you saw earlier this week, actually sent out a recorded interview that we did with Ricardo Malos. So if anyone is interested in getting involved with the content, hasn't got a topic to talk about, but would like to be interviewed about their business, their team, a project, please do reach out on that side of things as well, because more than happy to do that. But in the meantime, right now, I'll pass you over to Will. Obviously, as always, the talk will come first, question and answers will follow. So please, if you've got any questions, try and hold them to the end and put them in the chat function, and we'll do his best to answer any questions you got. But that's all for me from now, and I will pass you over to Will. Speak soon.
Hi everyone, thanks George. Right, I'm just going to do the preliminaries and share my screen if I am able to. Fantastic. George, could you just give me a shout if that's come through?
Yes, all good, mate.
Awesome, thank you. Hi, thanks for having me and for coming to this presentation. I'm going to talk to you tonight about event sourcing in NodeJS at a small scale. My name's Will. I'm going to tell you first just a little bit about myself, because I think it's always useful to know who's talking at you. This is a picture of me in earlier days before I was prevented from getting my hair cut. I've got a sort of quite a varied career in software. I reckon I started earning money from software in about 1996, which is a fairly long time ago now. A few different technologies and a few different industries. So I've done a number of things, a few different types of software development management. I've worked with product a lot. I've done the whole agile thing. I started a consultancy a few years ago, and right now I pretty much am a CTO, a startup CTO. So I work with founders from the very beginning of a company and give them support and work on building a team. And I also offer training and coaching to people in the software industry. Right now, I am working mostly with a company called Tempo, who I want to just say a little bit about. So Tempo is a platform for employers to directly hire workers, both permanent and temporary, specifically in office administrative roles, so secretarial and office management, etc., and also in customer-facing roles, so customer success, customer service, sales teams, things like that. And the focus is on really transparent communications between hiring companies and candidates, a really simple user interface and usability and video. Tempo was founded about 3 years ago in January 2017, and we launched our MVP in May of the same year. We hired our first employee, was a tech team member in June of 2017, and as of right now, we've got 33 employees. So we've grown pretty quickly, and it's kind of good times at Tempo. It's pretty exciting, and just a very quick note to say we are expanding our tech team. So I'm kind of doing a rounds at the moment. Technology-wise, it's JavaScript across the board. This is actually the first project I've worked on that used JavaScript as a full stack platform. I'd obviously had a lot of experience with JavaScript on the front end before, but at Tempo we use a back end of MongoDB and Node.js, React and Redux on the front, and obviously JavaScript. We're just getting started with TypeScript, and we're very keen on functional programming as a technology, which will maybe come through in some of the stuff that I'm going to present. So what am I going to talk about today? I'm going to talk about event sourcing, and I don't know how many of you have heard about event sourcing before, but it's a fairly hot topic, and I think it's one that's getting a bit of traction at the moment. So event sourcing is an architectural pattern which models APIs around events rather than resources. And often we compare it to REST, which maybe some more people have heard of, which models APIs around resources. Now, event sourcing works particularly well in conjunction with message-oriented technologies. So if you use something like Apache Kafka or message buses like that, and also distributed technologies. So I'm thinking things like Kubernetes, for example. And these things are often used by enterprise scale organizations, so really big organizations which have, I suppose, dedicated teams who can look at that kind of enterprise level software. But at the other end of the scale, maybe you're starting a startup or you're working on a really small personal project. Most small scale projects, I would say, use a CRUD model or a RESTful model. And many web development frameworks are optimized for that. So the question that I kind of want to pose is event sourcing too complicated to use in small scale projects? That's the question. Spoiler alert, the answer is no. And that's hopefully what I want to set out today with a few examples and some lessons learned, I suppose, from looking at event sourcing in small projects. So just the outline for the presentation. So we're going to start off by understanding the basic differences between CRUD and event-based design. Then I'm going to go through my personal motivations for developing an event source framework, and I'm going to touch a little bit about my experience in Tempo with that. I'm going to go through a reference architecture really quickly, and then we're going to dig into some code. Yes, I'm going to do a live coding demo. We'll see how that goes. And then I'm going to talk about the really good bits that I think we can get out of this stuff, and then what's next for some of this work. So let's start off by looking at the alternative to event sourcing, very traditional CRUD and REST. So two slightly separate things. I guess CRUD is a paradigm which models an API around 4 discrete actions: create, read, update, and delete. And basically they allow us to manipulate application state, which you can see on the right of this diagram, using one of those 4 verbs. CRUD's really, really old. I mean, decades old as an idea. Slightly newer is REST, representational state transfer, which effectively allows us to map the idea of CRUD onto a distributed system like the web, using a protocol like HTTP. So just running through an example here, we've got a system which the example here is maybe it's a to-do list API. And if we want to create a new to-do list in our system, we fire off a create operation, which would map to an HTTP post. And we post some message to a service endpoint, which triggers a creation in our application state. If we then want to read what we've written to our application state, we typically do an HTTP GET, which presents that back to the client again. If we want to update our system, so for example, if we want to mark our to-do list as red, or we want to rename it, there's a couple of ways that we could do that in REST. We could use a patch, or we could use a put, but pretty much those are the 2 verbs that we have to play with there. And again, that would update our application state. And another type of updating, I suppose, is deletion. So if we want to delete something from our system in REST, we usually fire off a HTTP delete verb, again, specifying exactly the thing that we want to delete for our application state. So this is all fairly standard, and it underpins a lot of APIs that are out there, I guess, in the web community. So let's just run through a quick example, looking at it at an HTTP level. So I've got a service. It's a to-do list service, and I'm going to start off just by doing a get on my to-do service on my endpoint here. This is HTTP, right? So all HTTP commands should generate a status code in response. Here we're generating 200 OK, which means that the get operation we wanted to do was successful. And we get a document back. This document is JSON encoded. And you can see here it's just an empty list. So this probably represents a system where we don't have any to-dos yet. Then what if we want to create a new to-do item? So here we would usually do an HTTP post. So we're making that post to the same endpoint that we saw before. We're providing a little document here, again, JSON encoded, which is the thing that we want to create, the resource that we want to create. And HTTP is giving us a different status code now, 201 created, which means I made you a new thing. And by convention, we return the thing that was just created. So here you can see it's a little bit more than we gave it. The system that we posted it to has also assigned it an ID and some other piece of application state here, whether it's done or not. Here, this is a Boolean, and our new to-do list item is not done, so done is false. If I then read my to-dos again, you can see that I've got a different response. I had an empty list before. Now I've got a document, which is the resource I just created. So what happens in a RESTful system when we want to make a change to some existing data? So we want to mark our to-do as done. Here we would use the ID of the document that we got back last time to construct a new URL, which identified that particular to-do item. We would then issue an HTTP patch command, and the patch command would somehow encode the thing that we wanted to change. So here we want to change the done field from false to true. And again, we'll get a 200 OK back from our server and a new version of the document. And then when I read my server again, you can see that I still have the same number of documents, but the field that I wanted to change in document 0 has in fact been changed. And exactly the same thing happens if we want to make any other modification in a RESTful system. So if we want to change the title of a to-do, for example, we do exactly the same thing. We do a patch to that item. The only difference is that the thing that we want to change about it changes. So rather than changing the done field here, we're changing the title field. Again, the response looks pretty much the same. And reading back out from our to-dos list, again, looks the same. And you can see here that it's just changed the title of the thing that we want to, of the to-do list item. Deletion is ever so slightly different. Here, whereas before we issued a patch command to our URL, now we're issuing a delete command to it. And again, an HTTP server typically responds with a 200 OK to that. By convention in REST, we often return the document that we just deleted, even though it doesn't exist anymore in our application state. So now when I've done my deletion and I read back my list of to-dos, I can see that it's once more an empty list. So this is all pretty sensible. Let's look at how an event source model might work. So we see our system here looks a little bit more complicated. There's arrows flying in all kinds of directions, but when you break it down, it's actually quite simple. The reading of application state is pretty much the same. We can do that if we want through an HTTP GET. It's the writing that's changed here. So instead of having those 3 verbs, delete, update, and create, we've got an arbitrary number of events here. So event 1, 2, and 3. And all of those get mapped in this convention to an HTTP post. And they go to an endpoint, which is basically like a catch-all endpoint for incoming events. From there, they get put into something called an event log. And at some point in the future, an event processor comes along and takes events off the log and does something with them in order to change your application state. So what that ends up with is this kind of circular pattern where mutations to our system come in through the bottom. They go through this route, and then when we want to read that data again, it goes out through the top. So it's kind of asynchronous, asymmetrical, if you like. So let's just go through an example in the same way of what an event-driven system might look like there. So when we create a to-do, we still make an HTTP post, although our endpoint is different. So we're posting to to-do/events. And our document is bigger. So we don't just post the title of a to-do list item. We also specify what verb we want to use. So here, because we're creating a to-do list item, our verb is create to-do. And then we've got this thing called data, which holds all of the parameters that are relevant to that create to-do item. Here, the only thing we need to specify is the title of the to-do list item that we're creating. Because we're using HTTP posts, we get a 201 created response back. And the thing that we get back here is not a new to-do list, but simply the new event that went into our system. And we must be careful here. So this ID is ID of event 0, not to-do list item 0. You see, if I read my application state through the same URL, I still get the same kind of thing. I still get a document, which is a to-do list item. Again, this is to-do list 0, not event 0. So I've got two different sets of things here that I'm tracking. Here's where the real changes are. So if I want to mark my to-do as done, remember we did a patch before. Here I'm doing another post to the same endpoint that I used for creation. The thing that's changed here is my verb in my document. So I'm changing the verb to mark as done, which corresponds to the action that I want to take. And my parameters are different here. Whereas before, when I was creating the to-do, I needed to pass a title. Now I need to pass the ID of the to-do list item that I need to mark as done. And you can see here, I get, again, a 201 created. This is just the fact that my event was created. It doesn't say anything about how application state was changed. In order to see that, I need to read back from my application state, and I can see here that, in fact, my done field was changed for to-do list item 0. Exactly the same thing happens for editing a title. So again, we're posting to the same endpoint. Our verb is different, so it's changed title. And here our parameters are the item that we want to change and also the new title. Everything else works exactly the same as it did before. And then delete. So remember that in a RESTful system, we issue an HTTP delete command. Here we are still doing a post to events, and it's only our verb that's changed. Our verb is now delete to do. And again, we're specifying the item that we want to delete. Assuming that the event was correctly processed, we can then read our application state again, and we'll see it's an empty list. So both these systems do the same things, they just do them in different ways. So why is this good? Why is this any better? I'm going to talk about the motivations that I had for using an event source system, particularly for a small project like this. So the initial motivations were auditability. So if we are constructing an event log of incoming events, we can keep that log forever. So it means we never need to lose any information. In a RESTful system, for example, when you change something through a patch command, you actually lose information because you're overwriting data. But in an event source system, you're just building up events in a log. We can also log other interesting metadata when we do this. So for example, a really basic example is user ID, like who is doing this action. But it could be other more interesting things like what browser are they using? We can get a really granular picture of exactly how users are using our system that way. If we have a log of events, in theory, we could use that in our product. So imagine you're building, let's say, an accounting platform. It's often really useful or even sort of critical to have an audit history in the product. So having that event log stored might be really useful from a product design point of view. But even if you don't use it in your product, it's really useful for compliance and legal reasons. So let's say there are legal reasons why you need to track exactly what is going on in your system. Maybe you need to keep a record of every single transaction that happens. You're going to need basically an immutable log to capture that. But even from a more practical point of view, it's really useful from a development perspective to be able to see exactly what happened in a system in chronological order. The second motivation I had was decoupling and domain-driven design. So one of the risks, I suppose, with RESTful systems is that you are tempted to couple them, the database schema directly to the user interface, just because it's so easy to do. We saw in the example earlier, the user interface knew all about how to edit to-do list items, and that could have been directly in the database. So the forced decoupling that you get from event source systems is actually really useful to just prevent you from doing that accidentally. The other really good barrier that event sourcing represents is that it doesn't allow you to mutate unless you have a strongly designed event in order to do it. So it means you have to be really conscious about your system design. You have to design all your mutations as specific actions in your event system. And a really good side effect of that is that you can, once you've done that, you can draw a complete domain map for all the things that can happen in the system. And that's useful for people in the rest of the business, for example, to be able to see exactly what a system's capable of. And on a related note, the semantics of those domain actions are typically really human readable. So if you think about those two examples I had, every single one of those actions, like marker to do as red or renamer to do, they make sense in plain English. They're very easy to reason about. So that really helps actually when you're doing business analysis on a problem. The third motivation I had, and this is maybe more of a personal thing, is that I really want the developer experience of this to be really good. Lots of companies work with developers with a range of experiences, and sometimes we can forget just how difficult it is to put basic systems together. So I really wanted to focus on maximizing developer time and maximizing ease of use. And really the way that we maximize time is to make sure that we're building as much as possible which adds value, rather than getting bogged down in boilerplate or just making really basic things happen. So I wanted a framework that made that easy. I wanted self-modularizing code. So I wanted to build a framework where it was really obvious where you needed to look for something, where you could just, everything that you needed to add involved adding a new file, just to keep the code base really clean and tidy. And I wanted to make something that was fun to use. I related a bit to the first point. So, you know, getting shit done just feels really good. I wanted something that was super productive, and that just made you feel that sense of achievement. I'm going to drill into the developer experience a little bit more. So one thing that's really important, I think, is coming up with a really strong pattern that people can use, because, I mean, we do need patterns when we build any kind of substantial product. And if we want to commit to a pattern, it's got to be both easy to use and powerful enough. I don't know how many people recognize this guy. He's called Larry Wall. He invented the Perl programming language. And he's got a really great saying that I love to come back to. So easy things should be easy, and hard things should be possible. So sometimes we just get that wrong. Sometimes we make everything really difficult, and that's problematic because it means there's a really high barrier to adopting a pattern. Sometimes, on the other hand, we make things, in trying to make things too easy, we make it so that some things we just can't do, and that means that generally we end up scratching around for just something, a completely different alternative, just because we can't do, let's say, 5% of the things that we want to do with a tool. So I think it's really important to bear that in mind when you're coming up with patterns. I wanted a pattern that was declarative. I think the benefits of declarative programming are pretty well understood. The main essence of it is that I just want to be able to describe what I want to build. I don't want to get bogged down in the details of exactly how that happens. Declarative programming also helps you centralize value in a small number of places. So it means that you can separate out the code that doesn't really add value, and by the way, we call that boilerplate. You can separate that out from the code that really does add value, which is the more declarative code. And also, declarative APIs means that we are forced to design our APIs first, so we can push the focus to more system level design and less to low level problems. And I think that speaks to a tendency that we have to really jump on low-level complex problems which represent too much risk too early in the process, and we kind of forget about the system-level design. So I think a framework which basically takes away that complexity and means you don't need to worry about it is really useful. So there we're thinking HTML. Super declarative language. Basically everything that you write in HTML, you end up seeing on the screen. A related technology, React. So I think one of the reasons that React is so popular is because you can really easily describe the thing that you want to happen and just see it happen. You don't need to spend a lot of time in imperative code just making things work. And GraphQL is another really interesting example. So there, the whole API there is declarative. You basically describe to your system what you want to get back, and it figures it out for you. The other thing that I wanted to concentrate on was tooling. So I really like bootstrapping tools. There's a slightly old-fashioned phrase, rapid application development, which makes me think of Visual Basic, which maybe isn't a good thing to remember, but it's still around, rapid application development. And the reason it exists is that trying things out and just making things work is much easier than reading documentation and trying to figure it out in your head. So here I'm thinking create React app. It's a really amazing tool that I think has been a massive part of the adoption of React. You can spin up a React app in seconds, basically, with this. Rails is another really interesting example. The reason why Rails was and is so popular is that it lets you get off the ground really, really quickly. It abstracts away some of the really difficult things that you don't really want to worry about. And maybe one that some people haven't heard of, Feathers.js. It's quite a cool framework for building RESTful APIs quite quickly, and actually gave me a lot of pointers when I was coming up with the event source system. I think there's more of these bootstrapping tools than we might think out there. But a caveat there is that escape hatches are a really good idea. So if you've used Create React App, being able to press that ejector button and get back into the real world where you can make some fine-grained changes is really important, as per Larry Wall's motto. And then the last thing, I put a question mark after, microservice ready. So there's a lot of noise about microservices. And I think one of the problems is that they're presented as like an either or thing. So you can either use a monolith or you can either use microservices. But the reality check there is that microservices are super hard to implement. My gut instinct is to start off with a service-oriented monolith, which allows us to really separate our monolith into services, but defers the really complex deployment problem of microservices to the point where we actually need it. And I can't count the number of conversations I've had with people who said they are currently underway in a microservice migration project. They just never seem to end. I haven't spoken to really many people at all who said, oh, I've just finished migrating to microservices. So I think that's a bit of a smell, really. All right, one slide on the reference architecture that I'm going to present here. So this is our service-oriented architecture, and I've drawn two services here to illustrate. Each service has 4 main components to it, all centered around this list of operations. So here, for our to-do list example, these are things like create to-do, mark to-do as done, edit to-do, title, etc. Now, the outside world can get access to these operations through a meta service component, and the endpoint here, by convention, I've called ops. So it can query this service and say, well, what can you do? When we want the service to do something, we can post an event to the events endpoint, which goes into this events receiver component. It also knows about the operations, and it can cross-reference them. So it can say, is this an operation that actually makes sense to me? If it does, it can post it onto this shared event store or event bus, which could be implemented in Kafka, for example, or it could be something more local. And then at some point, our service has an event processor which will subscribe to events that are happening on the event bus. And when it sees one that interests it, it can take it off the bus and process it. And when it does that, it typically manipulates application state, which can then be read back out of our service again through a state endpoint. And so service 1 and service 2 are identical. I've drawn a shared event bus here, which is typically, I think, how it works. The state I've drawn as separate to each service, although it could well be shared between services as well. I think that's a matter for the reader, really. Right, let's look at some code. Famous last words. Right. I have here an example application, to-dos list. So I can say, write this presentation. Thank God that worked. So you can see I've added a new to-do list to my item here. Give demo. I can delete to-dos. I can mark them as done. Now this system here, this is RESTful, as you might be able to see here. So let's have a look at one of these. See, here's the deletion command that I put in. So I'm deleting to-dos number 1. And here I'm marking something as done. So here's that patch command that we were seeing earlier. And the payload here, done, is true. So that's all well and good. But obviously we're trying to talk about event sourcing here. Oops. I've got a little demo project here, which is powering this, this user interface. And what we were seeing there is an API that I wrote under this folder, CRUD API. It's really tiny. It's just an Express app. It's backed by a in-memory database. Rather than use something real like Mongo, I decided to use an in-memory database, and it's got a number of functions on here. So create to-do, that creates the to-do list item in the database. I can read them all, I can delete them. So this is all ready to go. And that CRUD API, it just calls directly into those database functions. So what I'm going to do is I'm going to try and build the same application, but using event sourcing. And in order to do that, I've set myself up with a template in a product called Yeoman. I don't know how many people have used Yeoman, but basically it gives you a tool set to create boilerplate projects. And I've called my project here, I've called it Squirt. It's a play on words on event sourcing, you know, like tomato sauce or whatever. It's actually really hard to find a free name in NPM, but I think Squirt is available, so please don't take it. So I'm going to create my new Squirt project. A little bit of thinking, and then, okay, so it's saying to me, what is the folder name you want for your event sourced application? The default is API. I'm actually going to call it ES API to be consistent with the CRUD API that I've written up here. Okay, it's gone and done something. It's created 4 files for me, and it looks like it's doing an npm install as well. Let's find the files that it's created. So here we go. So this is now the shell of an event sourced server, basically. And you can see here it's created me a services folder. That's where all my services are going to go. But mostly the code in here is just skeleton. I'm still waiting for my npm install to finish, I think. But once I've done that, I'll be able to do the next step. Excellent. So that's my skeleton project created. Now what I'm going to do is I'm going to create a new service. So it's a very similar command, npm yo squirt service. And here I'm going to get asked a different set of questions. So what's the service name? I'm going to call my service to-dos. Would you like to publish the service? This basically means, would I like this to appear in the directory of services that you can query on that meta endpoint I was talking about? I'm going to say yes. It's created a bunch more files, and it said there's a conflict because an existing file needs to be overwritten. I'm just going to accept it. So now we can see that I've got a new folder in my services folder called to-dos. And here we've got, this is basically all boilerplate code that it's created, which knows how to implement an event source server. And then the last thing that I need to do using my trusty Yeoman tool again is create some operations. So I'm going to create an operation here. I need to select the service I want to create it on. Yeoman has detected that I have one service called to-do, so that's the only one I'm allowed to select. It's then saying what verb I want. So I'm going to create an event called create to-do. And I'm going to give it a description. And here's one I prepared earlier. Create a new to-do item within a list. Would you like to add a parameter? Yes, I would actually. I need to give my to-do list item a title when I create it. And it's giving me a list of different data types that that parameter could take. I'm going to say string. And again, I'm going to just paste this from my little grab bag here. So this parameter is the title of the to-do item, to create. Would you like to add another parameter? No, I wouldn't. Awesome, it says there's another file conflict. That's fine, I'm going to overwrite it. And now we should see that I have in my operations folder a new operation, create to do. And this is what I asked for. So this is the real magic of declarative programming, right? So everything else that we see here is basically boilerplate. This is the essence of what I wanted to make. It's an operation that creates a new to-do list item. And here's all the metadata that applies to that item. All I need to do here is fill in some implementation. So I'm going to need my database layer injected. And I'm going to say db.create-to-do title. So I'm just wiring up here. And then I need to do a couple more things. I need to inject my database into my dependency injection system. This is another topic I'm really passionate about, but I don't have time here to talk about it. I think dependency injection and version control is really important in sustainable development. But all I'm doing here is I'm adding the database to the container of things that's available to my operations. And then I need to do one more thing, which is my state endpoint. I need to be able to return the list of to-dos from there. So again, I'm going to need access to my database layer. I'm going to do database.get all to-dos, I think I called it. Hang on, let me check. Yeah, that looks great. Awesome. Right, I'm going to try and run this now. That looks good. Looks like my server's running. So here is an event source version of the to-do list app. I'm going to give it a go. So write this presentation. Excellent, that worked. So it looks exactly the same user interface, but actually it's using my event sourcing server behind the scenes instead of the CRUD server. And you can see that here. So here we're posting a new event. That's a create to do. I've given it the title of the item to create. And what I've got back is basically a confirmation that it's created my event. There's a little bit more stuff here. So I can see that my event has actually been processed. It was processed in time to actually return that response in the initial HTTP request. If it had been a really long running event that took a while to get processed, then it would just basically have said, I've created you an event, but it's not been run yet. You can see I've still got my state endpoint here for querying my to-do list. I can actually look at the API. So that's my application state. And here is a list of events that are in my system. So if I create another one, that's added it to my to-do list, and it's also added it to the list of events that have been logged in my system. So you can see I'm starting to build up an audit log of everything that's happened in my to-do list application. If I try and delete it, it won't work. You see I get an error here. And also if I try and mark it as done, it won't work. And that's because I haven't implemented those operations yet. So I would need to go back to, let's say, to the command line and run them all. As it happens, I have a git stash that I've already written them in. So let me just apply that. Oops, I need to remove that conflicted file first. Do that again. Fantastic. So now if I look back in my code base, I can see I've got all these operations that I've written. And notice here's the modularity, right? So every time I want to add a new feature to my application, I add a new file, which is a new operation to run. And they all look very similar. They've all got a definition and then a set of instructions for what happens when I want to actually process them. So hopefully now, assuming my server's rebuilt, Yes, because my memory database is gone. So let's try this again. Write this presentation. Another. I'm going to mark this is done. That worked. That worked. And then I'm going to delete them both. So if I look at my application state, you can see it's empty. That's exactly what I can see on my screen. But if I look at my event log, it's actually got a log of everything that happened still. So here's the initial creations. Here's me marking stuff as done. Here's me deleting to-dos at the end of the day. So we haven't actually lost any information here. Excellent. So that is the code. I'm just going to run through some of the real good bits that we can get out of this. So cross-cutting concerns. These are really common. So it's often that we want not just to do some business logic, but also to do something that applies across that logic. So for example, debug logging or notifications or authentication, something like that. I'm actually going to show you in the code here. So when we process our events, we have this pipeline that says how they get processed. And after they're processed here, I'm actually logging out the processing on the console. So if we look at my server, you can see everything that I've done has been logged out on the console. I can add because all the events are treated in exactly the same way, it's a really consistent pipeline. So I can apply another state and another to apply to all the processed events. So I actually have another logger here, which is a Slack logger. Let me just, oops, one more up, demo, Slack logger. So I'm going to run my Slack logger after the console logger. So I just need to change this in one place, and every single event that I have that goes into my system is going to be reported to Slack. Let's give it a whirl. So blah. Oops. Oh no. I did something wrong there, didn't I? Slack logger. Okay, that looks better. Blah. I don't know if you heard that click. That was a Slack notification coming through. And you can see here, I've got a dedicated channel here, which has said, create to do event occurred at Thursday, 4th of June at this time. If I delete the item, I should get another one. Yep, there you go. So that's me deleting something. This is super useful. And it really helps when you're building an MVP, for example, to be able to connect your application to Slack and just see what's going on. And notice I didn't need to actually do anything here apart from to add a logger, which fed the information directly through from the event sourcing system to Slack. So cross-cutting concerns can apply not just across the board, but also on like a per operation level. So we can add other things to our operation processing pipeline, like authorization, for example. Are we allowed to do this action? Or validation, is the application state such that at the moment we can sensibly run this action? I'm not going to demonstrate doing that, but it's really quite possible using this kind of system. Analytics is another really good advantage of this. So this is some real data from Tempo, actually. When you have an event pipeline that just receives events agnostically, you can spit them directly out again into a system that looks at analytics. So actually here they're going into Elasticsearch, and we're using Kibana to report on them. So this is a log of all the events that represent chat messages between employers and candidates on the Tempo platform in a certain time period. And again, we didn't need to actually do anything to support this. All we did was wrote a little tiny function to take the event that was coming in and pushing it into Elastic. So it kind of comes for free, and it's really, really powerful. Slack Ops, this is one of my favorites. And the last time I did this, it didn't work. So let's give it a go. Although we can get notifications through to Slack, we can also have the communications happen in reverse. So remember that meta endpoint that I had on my services. I can write a command in Slack to query that. Oh, fantastic, it worked. So this help text that I've got here, this is Slack saying to my event sourcing server, what can you do? And it's given me a list of all the things that it understands. So you can see here, it knows I can create a to-do, it knows I can delete one, it knows I can mark them as done, and I can fire this off from Slack. So I can say, run ops to do, create to do, use more Slack. Fantastic, I got a little green tick there to say that it ran. And then if I go back to my to-do list application, you can see I've literally created that application state change using Slack rather than using the user interface. And this is something that we've used at Tempo to great effect, because it means that you don't need to necessarily develop and design a UI just to test a feature. You can make a beta feature and test it out just using a command line interface like Slack ahead of time. It's really, really powerful and really, really cool. The other thing that we found out that you can do, similar to Slack really, is that, like, why limit yourself to Slack? Actually, you could do any of this stuff from the command line. So here we've got, I can type in CLI ops create to do another. That did not work. No, I might give up on that one. If that had run, it should have done exactly the same thing that we did in Slack. It should have, oh, I'll tell you what, I forgot the service. There you go. And you might have heard the click there on Slack. So there you go. I've run that from the command line, and it's created another to-do list item, which is really cool. And we found that also this has loads of benefits in automation. So for example, if we want to set up a test system and fill it with data, we can just create a kind of script file to do that and run that through the command line too. So for example, I wrote a JSON file here, which creates a to-do, marks one of them as done, and changes the title. Or I could do it as a text file. Oops. Text. So here's a list of loads of things I can do on a system. I'm on that one now. If I do ops batch script.text. All right, you probably heard quite a few Slack notifications happening there. So what that's done is it's cleared out all my to-dos and created a bunch more and then renamed them. So if I refresh my screen, you should see I've got a whole new system. This is fantastic for automation testing because it means you can wipe your system down, script up a bunch of changes, and get your system into the state that you want it. It also means you can capture and replay events to get your system back into a state which is particularly interesting to you. And it means you can do things like migrate to a different database really easily, because all you need to do is replay your events. Okay, so lastly, what's next for this stuff? I think it's really exciting. I'm really pleased to have put together a system that allows you to do this, what I think is an excellent way of working, in a much easier way. You've seen how quickly it was for me to throw this application together. Other things that I would like to look at. So it would be really good to delve a little bit more into the event bus. It would be good to have a reference Kafka implementation here. I don't know if anyone's ever used Kafka, but it's a pretty cool bit of technology. It's not one of those things that you can use out of the box, but it would be really nice, I was mentioning escape hatches, to be able to switch over to a common event bus in the cloud, for example. I really want to look at containerizing some of the services that are generated here, so that if someone did want to move this to like a microservice framework, it would be much easier. I think that the Slack ops is a really cool thing, but it can probably be improved in terms of the tooling. So maybe a little bit more of an interactive way of running commands from Slack with dialogues, for example, and actually having a unit test framework that can run against a system like this is really important if people are going to pick it up out in the industry. And then possibly a reference analytics integration. So I demonstrated very quickly how you can plug this into Elastic as one avenue, but perhaps there's a better system out there that really showcases the analytics potential of this. And then ultimately, it would be great to be able to open source this. Every time I have a conversation with people in the industry about it, they get really excited. And I and Tempo as a company also would love to be able to share this with the community someday. So please watch this space and get in touch if you're interested in contributing. And that is my presentation done. So I'm happy to open the floor up to questions. George, shall I just go through the chat things?
Yeah, I think there's a few in there, Will, so feel free to have a look at those.
Okay.
Guys, if you've got any questions, feel free to put them in the chat function for Will.
Yeah, okay, I'm just reading through now. Please, could you share this code base? Yes, maybe not right now, but soon. I'm trying to get to a position where it's ready to share. There's just a couple of bits in there that I'm going to need to take out, but yeah, I will try and keep everyone posted. I don't know if there's a good way to communicate that, but we'll find a way. Good name. What about the security on event sourcing? Not sure I quite understand that question. Byram, if you want to maybe post a follow-up to that to explain a bit more. Attila says, so are all requests to a service is becoming an event directly? Do you not separate commands from events? Commands as in the request client make from events description of what actually happened? I think that's a really good question. And I don't have a straightforward answer to that. I suppose one of the key rules, I think, is that everything a client does should be an event. For obvious reasons, if you have things that clients do that aren't events, then you lose all the benefits of your event source system. As for events that the system generates for itself, I'm not really sure. I mean, one school of thought says that you maybe shouldn't treat those as events in the same way. There's another school of thought that says you can treat them as events, but maybe you should tag them as not user-generated events. And it really comes down to whether those events, whether they're the primary event, I suppose. So, yeah, good question. I don't have a good answer, I'm afraid. Thank you, Byram, for helping with my coding. I missed that earlier. Sanjeev says, how to retrieve transactions. Not sure I entirely understand the question, but I guess there is a problem potentially in event sourcing that things need to be processed in order. And that can be quite problematic. It can turn what effectively could be an asynchronous system into a synchronous one, which has potentially some performance implications. If we're talking about transactionality in terms of, well, can we wind back the clock and cancel things? I think the route event sourcing leads us down is to not do that. But once an event has been applied in the system, it sticks. And in order to reverse it, you need to kind of apply an opposite event. And if you think about the way accounting system works, usually when you make a change to a bookkeeping or accounting system, that change stays forever. And the only way that you can reverse it is by putting another change in to void or reverse that original transaction. So I think.
Hello.
Hello.
I'm Sanjeev Kumar. Yeah. So what I was asking is, if I want to do multiple events in a transactions, like if any of them fails, I want all to be undone. How can I achieve that?
Yeah, I don't think that this kind of paradigm necessarily sets out to solve that problem. I think you have the same problem in a RESTful API, right? If you're looking at the API level, how does your user interface know that it's done one action that's failed and then it doesn't need to do the others. So I don't think that
in the API level, in the REST API, whatever one API can perform multiple events, right? In a transaction, in a DB transaction. So how can I do the same thing in the event sourcing? That's what I want. You understand my question?
Yeah, I understand. I think that comes down to your API design and how you handle it. You can definitely build transactionality in at the back end if you want. It just really depends how you design your API and what actions you try and map to. I'm gonna just move down the list again. So thank you for all the compliments. Question: with an event bus, would writes be async? If so, how do you handle read consistency? Yeah, I like that. That is a good question, and one I alluded to earlier. I think it depends. Again, it depends on how sensitive to ordering your processing systems are. You could imagine a totally asynchronous system that just doesn't care what order the events happen in. I think most systems actually don't work like that. So you need to probably track what order events come in and make sure that services are only modifying state when they're ready to modify state. What do you recommend to do in terms of doing some upfront design before implementing, or is it quite easy to extend and modify afterwards? Was there something that you thought would be easy but turned out to be difficult in building this so far? Okay, 2 questions there. So the first one, upfront design. Yeah, I think this leads you down a path of developing quite a strongly typed API, and it means that you need to be really careful about upfront design, because if you change, let's say, the parameters or the semantics behind an operation, you might end up with a system that just doesn't quite understand the historical events that have happened. So I think one strategy there is diversion events. That adds quite a lot of complexity, but it would certainly work. I mean, you're effectively just changing the name of an event. But our strategy so far has really been to try and get that API design done and correct. And if we wanted to change anything, using that kind of open and close principle, to maybe prefer just adding a new event type rather than modifying an existing one. The second question, was there something that you thought would be easy but turned out to be difficult in building this so far? Yeah, I think it's come up a couple of times in these questions, but that kind of the concurrency and breaking out of that request response cycle that you're really used to in REST is really difficult. So the demonstration that I gave here actually had somewhat of a fudge in it. I don't know if you'd necessarily call it that, but basically because events are processed asynchronously, they go onto a bus, and then the original request is waiting for a certain period of time just in case the event gets processed super quick. And if it does, it returns back a signal to the user interface to say, actually, I've received your event and it's finished processing. What you can do when the event takes longer to process than you want to wait for in the request response cycle is really quite complicated. And you need to build in something on your client side then to handle it, whether that's WebSockets or some kind of polling mechanism. And I don't necessarily have a recommendation there for how to handle that. Last one by the looks of it from Sean Stone. Is the verb in the payload the normal convention? We do verbs in the URI. Yeah, I can definitely see verbs in the URI working. Yeah, I don't know if there is such a thing as a normal convention here. I guess that's what's so exciting about it, is that we can kind of make up the rules as we go along. I can definitely see good advantages in having the verb in the URI. Yeah, I'm not gonna have a particularly strong opinion about it, I think. Paul Dickinson, we are attempting event sourcing with microservices. We have a problem representing other microservices data, e.g. my to-do app may not know about a registered user's first name but want to know Any thoughts? Yeah, that is a tough one, and I think that comes down to how isolated your microservices are. Whether they, I mean, you can take a really strict point of view that they never share state and they don't rely on state from other services. Now that's quite restrictive, because it means that if you have a domain concept that needs to span services, like how on earth can you share that information? I think a few strategies are out there. You could just share the state, right? You could just have a database that all the services have access to, which would make sense, but that doesn't scale necessarily too well. Another thing that you could have, and this relates to maybe one of the previous questions, is you could have another level of events. So you could have a set of events going on that acts to kind of synchronize services behind the scenes, but aren't kind of primary level events. There you start building in, I guess, quite a lot of complexity in the design, but it does leave it really nice and loosely coupled and potentially more scalable. Those are my, you asked my thoughts, those are my thoughts. I'm afraid I don't have any definitive answer. It's one of those tough ones, I think.
Okay, thank you. I think we're going along the lines of kind of syncing with events.
Yeah,
So
I'd be really interested to know how you get on with that.
Okay, thanks.
Brilliant, thanks, Will. Really good chat as always. Really good content for everyone to watch and view. Obviously, we've recorded the session as always, so that'll be live on YouTube and shared out with all of those that haven't been able to join us this evening. If anyone is interested, like I mentioned earlier, in giving a talk, either on representing yourself, your business, your team, please do feel free to get in touch. And yeah, as soon as we've got someone lined up, we will share the content. But thanks very much from me, all the guys at Oliver Bernard, and from Will and the guys at Tempo as well. And we'll see you all soon. Cheers. Bye.